Hello everyone and welcome to the session number 4 of our course Database Design and Implementation. In this session we will talk about data modeling and ER diagrams or entity relational diagrams. Let's start. First, let's remember together what's the difference between the relational and non-relational databases. The relational databases like MySQL store data in tables with rows and columns. They are great for structured data. The non-relational databases, also called NoSQL databases like Mongo database, they store flexible data such as documents or key values pairs, like dictionaries. They are good for big or unstructured data. And now that you know the difference between relational databases, SQL, and non-relational databases, NoSQL, you have seen how SQL databases use structured tables and schemas and why they are perfect for transactional systems like banking, e-commerce, or finance. How do SQL databases make sure those transactions are done correctly, even if something goes wrong midway? The answer lies in something called ACID properties. And now let's explore them together. What ACID stands for? A for the atomicity, C for the consistency, I for the isolation, and D for the durability. These are the 4 rules that every transaction must follow in the relational database. Let's break it down simply. Atomicity, all steps of a transaction must happen or none at all. No half-done updates. Consistency, the database starts and ends in a valid state. Data rules are never broken. Isolation, even if 2 users do transactions at the same time, they won't interfere with each other. Durability, once a transaction is done, it stays done, even if the power goes out. These rules are what keep your database safe, correct, and reliable. And now let me present this example. I can say this is an example about bank transfer. Here we have this transaction. Alice is sending $100 to Bob. 2 things happen. $100 is removed from Alice's balance. Okay. And this $100 is added to Bob's balance. These steps are wrapped inside a transaction. And how we can write this using SQL? We can write a code like this one. This code will start with begin, ends with commit. Why is this important? If the system crashes halfway after taking the money from Alice, but before giving it to Bob, ACID ensures that both actions are cancelled, not only just one. No money is lost, no account is corrupted. And now let's go back to the 4 vocabularies. Atomicity, if one update fails, the whole thing is rolled back, no money disappears. consistency, the total balance before and after the transfer remains correct. So the money will not stay in the middle between Alice and Bob. Isolation, even if another transfer is happened at the same time, it won't affect this one. They will not be mixed. Durability, if the server crashes right after the commit, the transfer is still saved. It will not disappear. ACID gives us trust in relational database. It makes sure no weird data errors or system crashes can cause damage to the system. So now you know how SQL databases protect data using transactions and ACID, but how do we organize the data before writing any SQL at all? That's where the next concept comes in, data modeling. Now, what's data modeling? Data modeling can be defined as the process of drawing a picture of your data before you build the actual database. It helps us understand how data is used, stored, and related to each other. It saves time, avoids errors, and ensures your database works well. It's similar to the algorithm or the flowchart that you can write before starting the coding using one programming language like Python or C++, etc. So drawing the entity relational diagram will be helpful to discover the mistakes and understand everything before starting coding the databases. There are 3 levels of data modeling: the conceptual level, the logical level, and the physical level. Conceptual level or conceptual data model is the big picture, and here we need to identify the main entities in the database like student, course, enrollment, order, customer, etc. The logical data model, here we add more details like relationships, keys, data types. For each entity, we need to add a lot of details like what are the attributes of the student, what are the columns, the types of data, everything. Then we have the physical data model, which is the actual database designed for specific database management system or DBMS like MySQL. And after adding all the details using the logical data model, in the physical level, we can add more advanced queries like indexes, filters, etc. So how we can find easily the data in the database. Why should we model first? Because it helps us to understand the requirements, understand better the requirements, find problems early, because it's very, very difficult to modify the requirements after they cause problems. communicate clearly between the technical and the non-technical team, because the technical team is the team who writes the code, and non-technical team is the team who design the database. Save time later. So if we need to modify something or find the error, so we can go directly to the model and find what's the part who causes the problem. And now let's go to another conception, which is the key terms in data modeling. In the data model or the entity relational model, we can find three essential terms, which are the entities, the attributes, and the relationships. Let's start with the entity. The entity is like a noun. Example, we have student, course, as I already mentioned, customer, order. So it's just this part here. This is one entity. It can be defined as an object or concept about which data is stored. It represents a real world item. Then we have the attribute, which is a property or characteristic of an entity. Each entity can have more than one attribute. For example, here for the student, we have student ID, name, email, date of birth. For the courses, we can have also course ID, course title, etc. Okay. Then we have the relationship, which is a connection between the entities. Example, if we have entity student and entity course, we can find in the middle the relationship enrolls in. Student enrolls in course. And now, because here we have some attributes like student ID, course ID, so what are the constraints if I want to write the student ID in the student table? Is there any constraint? So now I will explain simply these constraints, and then during the next sessions I will add more details about these constraints. Let's start with the primary key. Primary key is a unique key for each record. For example, for the student ID, we should not find two students with the same ID. Each value must be unique and not null. Okay, so here we have two constraints with the primary key. If we identify one attribute as primary key, it's like if we added two constraints, unique and not null. Okay. And now let's go to the foreign key. Foreign key can be one or more columns in a table that refers to the primary key in another table. This foreign key is helpful to connect tables together. Like if we want to connect table courses to table students, so we can use the foreign key. Here we have another example. We have employees and department. In the table employees, we can have employee ID, which is primary key, okay, because we should not have two employees with the same ID, name, department, etc. And here we have another table, which is department. We have department ID, department name, etc. And in this table, the employees, we have department, and it's another table. Okay, so this employee is working in this department. In order to not be confused with the departments, because maybe here I will add for the employee 1 department 4, but look in the table of departments, we don't have any department number 4. This will cause problem. For that, using the foreign keys is very important to attach one table with another, and this foreign key will refer to the primary key in another table. Okay, so this is the foreign key. This keeps data connected and avoids mistakes. And now let me present the difference between strong and weak entities. Strong entity exists on its own. For example, a student. This is a strong entity. Weak entity depends on another strong entity. For example, the dependent needs employee. For example, on the system of organization, the employee page sometimes contains the children of this employee. So the children can be weak entities. For example, for me, on my page, on the system of my campus, I can see my children, but they are related to me. They are depending on me. So if I don't work in this campus anymore and they remove my records, the weak entities will be removed with my record. So this is the meaning of the weak entity. And then let's compare between simple and composite attributes. Simple attribute is composed of one vocabulary like age, gender, and it cannot be broken down further. And the composite attribute can be divided into smaller subparts that are also meaningful, like full name can contain first name and last name. The address we can find inside, or we can divide into subparts like street, city, zip code, etc. And now let's go to the derived attributes. The derived attributes are not stored directly in the database, but they can be calculated from other attributes. For example, we don't need to add the age of the employee or of the student. It's sufficient to add the birth date, and it's better because the birth date is fixed, but the age is changeable. So if you add the age for one student, for example, 18, Next year, it will not stay 18, it will be 19. So it's better to write the birth date, and the age will be calculated automatically from the birth date. And this attribute can be called the derived attribute. Okay, another example. Total price can be derived from unit price multiplied by the quantity. So these are derived attributes. And now let's go to the relationships in the entity relational model. When we connect entity with another one, we should identify the type of relationship between these entities. This is very, very important before starting coding using SQL. We have three types of relationships. We have one-to-one, one-to-many, many-to-many. One-to-one, it's like a person with passport. Okay, the person can have only one passport for one country, and the passport can be related to only one person. Maybe you will ask, what's the zero here? The zero shows that this is optional. So the person is not forced to create a passport. The ID, it's okay. He is forced, so it's one-to-one, not optional. But the passport is optional. Okay. And now one-to-many relationship. It's like the relationship between employee and department. The employee can work in only one department, and that department contains more than one employee. Last one, many-to-many relationship, like the relationship between student and course. Student studies several courses. The course contains several students. This is many-to-many relationship. So the numbers that we can see here, 1, n, etc., are the cardinalities. We call them the cardinalities, as I already mentioned, 0 for optional, 1 mandatory, and n for many. 1-to-1 is exactly 1, 1-to-n, 1-to-many, or n-to-n, many-to-many, optional to many, optional to 1, etc. Before starting drawing the entity relational diagrams, I want just to present the shapes that we can use for this ERD. And if you can see here, we have some shapes a little bit similar to the flowchart that we used already for the algorithms. But here we have other meanings. First one, the rectangle can be used to present an entity. We have other symbols, but these are the most important symbols. Okay, so here we have the entity, rectangle, the oval shape to present the attributes, and then we have the diamond to present the relationship. If you want to add a derived attribute, you can use this dashed oval. Okay. So these are the main shapes that we can use to create an ER diagram or entity relational diagram. And now let's have this example. It's about a school system, but it's very, very simple, just to show you how we can draw the ERD, or entity relational diagram. Here we have these two entities, and between we have this diamond to show the relationship between student and course. And we can consider this as entity also, because we can add attributes to the relationship, and we will see later that for these relationships we can create tables similarly to student or to entities, to the main entities. So how we can read this figure, how we can read this diagram? Here we have the student, the attribute of students. I repeat, this is very, very simple. Here we have the course, attribute of course, enrollment, relationship between student and course. Also for the enrollment, we can add attributes. Okay, so to draw this ERD, we can find a lot of softwares online for free. So we can use the shapes there and draw this diagram. This is another way to show the ERD, entity relational diagrams. For example, here we have library system. We have here users, members. The user can be only one member, and the member can be related to only one user. So here we have one-to-one relationship. Book with member. Okay, so here we have book title, author, book copies. Here we have the attributes, and also here we have the attributes of users. Here we have the attributes of book. The relation between book and member, it's one to many. So the member can borrow or can read a lot of books. One book on the same time can be borrowed with by only one member. Okay. This entity, it's book issuance detail. The relationship between this entity and member, it's many to many. Okay. The member can borrow a lot of books. The book can be borrowed by a lot of members. So it's something like this. But just I want to mention that you as a database designer, following the requirements of your client, you can change this. So it's not a rule. Always we have this relationship between member and book, or between this entity and this entity, many to many, one to one. Everything is depending on the requirements of your client, okay, and your vision as a database designer. And here we have this exercise. It's about bookstore system. I want just to ask you to try to design this database using the normal entity relational design like this one, the shapes that we know already. Okay, so try to design this database. I will give you time to do this, so you can pause the video, try to draw the ERD, and I will show you the result. So I hope that you finished this design, and this is the result. It should be something like this. I will not say exactly like this, because I told you it's always related to you how you can imaginate your system. Okay, so this is everything about the ERD. Thank you for watching. In this session, you learned what's data modeling, key concepts and relationships, how to create an ER diagram. See you in the next session. Bye bye.